Bismillahirrahmanirrahim. Assalamu alaikum. I hope you all guys are good. In this video, we will discuss the 8086 microprocessor. But before discussing 8086 microprocessor, we will see what actually the microprocessor is, what are its features and its working. So the contents that will be covered in this video presentation are microprocessor, building concept of microprocessor, working of microprocessor, introduction of 8086 microprocessor, its block diagram, features of 8086 microprocessor, general purpose registers, flag registers, segment registers and offset, applications, advantages and disadvantages of microprocessor. Let us define microprocessor. So the microprocessor is a multi-purpose clock-driven register-based digital integrated circuit which accepts binary data as input, process it according to the instructions stored in its memory, and provides result as output. So basically microprocessor is computer's CPU on a single chip that contains millions of transistors connected by wires. In other words, we can say a microprocessor is designed to perform arithmetic and logical operations that make use of small number holding areas called register. The operations of typical microprocessor includes addition, subtraction, comparing two numbers and fetching numbers from one area to another. Moving on, building concept of microprocessor. So the microprocessor is capable of performing various computing functions and make decisions to change the sequence of program execution. The microprocessor is divided into three segments as shown, which are arithmetic and logic unit, register array and control unit. These three segments are responsible for all the processing done in a computer. Arithmetic and logical operation. ALU is the unit of microprocessor where various computing functions are performed on the data. It performs both arithmetic and logical operations. The arithmetic operations include addition, subtraction, multiplication, and division, whereas the logical operations are AND, XOR, NOR, NOT, exclusive OR. Next, register array. Register array is a part of register in microprocessor and consists of various registers like accumulator register, base register, and many more. It consists of registers which are small memory locations of high speed and are used to store and transfer data which is currently being executed. Control unit. Control unit provides the necessary timing and control signals to control all the operations in microprocessor. It controls and executes the flow of data between microprocessor and peripherals. The control bus is bidirectional. Now let us see how the microprocessor works. So to get the output, the microprocessor first fetches the instruction from computer's memory and then decodes it and executes these instructions as a result in binary form. So the power of microprocessor is measured in terms of bits. The first step in the working of microprocessor is fetching. So instruction fetching is the first step of microprocessor which fetches the instruction from the memory. Next, decoding. Instruction decoding is the second step of microprocessor which decodes the instruction. And executing, it is the last step of microprocessor which executes the instruction and gives the output. Now we will discuss the main topic of this video, which is 8086 microprocessor. So basically 8086 microprocessor is the enhanced version of Intel 8085 microprocessor. It was designed by Intel in 1976. The 8086 microprocessor is 16-bit N-channel high-speed metal oxide semiconductor microprocessor. Intel 8086 microprocessor is based on a single semiconductor chip and packaged in a 14-bit IC package. The type of package is dual inline package. 8086 is the Intel's most successful line of processor. It is designed to operate in two modes, which are minimum mode and maximum mode. Here we will see the block diagram of 8086 microprocessor. Looking at the block diagram, we will see that 8086 microprocessor contains two independent functional units, which are bus interface unit and execution unit. So this portion of block diagram represents bus interface unit of 8086 microprocessor and this portion indicates execution unit of 8086 microprocessor. Segment registers, instruction pointer and 6-byte prefetch instruction key are associated with the bus interface unit. The bus interface unit handles transfers of data and address. It fetches instruction codes in first in and first out registers set guard, quiz, and read data from memory and I/O devices and write data to memory and I/O devices. Bus interface unit has the functional parts which are instruction queue, segment registers which are 4 segment registers including code segment, stack segment, data segment, and extra segment, and the instruction pointer. Bus interface unit relocate address of operands since it gets relocated operands addresses from execution unit. Execution unit tells the bus interface unit from where to fetch instruction or where to read the data. The second functional unit of 8086 microprocessor is execution unit. The execution unit receives opcode of an instruction from queue, decodes it, and then executes it. While execution unit decodes and executes an instruction, then bus interface unit fetches instruction code from memory and store them in queue. These 4 general-purpose registers: stack pointer, base pointer, source index, destination index, ALU, flags and operands, timing and control unit constitute execution unit. Both the bus interface unit and the execution unit operate in parallel independently. So this parallel independently make the processing speed faster. Now we will discuss some features of 8086 microprocessor. So Intel 8086 uses 20 address lines and 16 data lines. It can directly address up to 1 megabytes of memory. It consists of powerful instruction set which provides operation like division and multiplication very quickly. It has instruction queue which is capable of storing 6 instruction bytes from the memory, resulting in faster processing. It's the first 16-bit processor having 16-bit ALU, 16-bit register, internal data bus, and 16-bit external data bus, resulting in faster processing. It's available in 3 different versions based on the frequency of its operation. It supports pipeline architecture. As we know that interrupt is a process of creating a temporary halt during program execution and allowing peripheral devices to access the microprocessor. So the 8086 microprocessor has 256 vector interrupts. Now we will discuss the general purpose registers of 8086 microprocessor. So there are 4 16-bit general purpose registers of 8086 microprocessor which are named as AX, BX, CX and DX. AX for accumulator register, BX for base register, CX for counter register and DX for data register, which immediate values during the execution of instruction. Each of these 16-bit registers are further subdivided into 2 8-bit parts that are higher and lower part. So discussing AX register, accumulator register, it holds operand and result during multiplication and division operation. Base register, BX register, it holds the offset register in indirect addressing mode. Counter register, CX register, it holds count for instructions. Data register or DX register, it is used with accumulator register to hold 32-bit values during multiplication and division operation. Now we will discuss the flag registers of 8086 microprocessor. So the flag is a special purpose register. Its size is of 16-bit. So it is basically a 16-bit register which exactly behaves like a flip-flop. Means that it changes states according to the results stored in accumulator. It has flags and they are divided into 2 groups, which are conditional flags and control flags. So the conditional flags represent the result of last arithmetic and logical instruction executed. Conditional flags are carry flag, auxiliary flag, additive flag, zero flag, sign flag, and overflow flag. While the control flags control the operation of execution unit, these include trap flag, interrupt flag, and direction flag. Depending upon the value of result after any arithmetic and logical operation, the flag bits become set or reset. Let us see segment register. A segment register contains the addresses of instruction and data in memory which are used by the processor to access memory location. It points to the starting address of a memory segment currently being used. So there are four segment registers in 8086 microprocessor which are named as core segment, data segment, stack segment, and extra segment. While talking about the code segment, so code segment of the memory hold instruction code of the program and offset register is instruction pointer. Data segment, the data variables and constant given in programs are held in data segment of the memory and its offset is relative to stack index. Stack segment hold address and data set routine. It also holds the content of register and memory location and its offset is relative to destination index. While the last segment register is extra segment and it holds the directional addresses of some data containing string instruction and its offset is relative to stack pointer and base pointer. As we all know that microprocessors are made by silicon or germanium. Both are semiconductor. Almost all electronic components are made by these semiconductors. So a microprocessor is an integrated circuit that contains a few millions of transistors fused on a semiconductor chip. It is just a few millimeters in dimension and it is used in almost every electronic device from small microwave oven and washing machine in homes to advanced supercomputers of space stations. So some of the basic applications of microprocessor include gaming, web browsing, creating documents, simulation, mathematical calculations, and many more. Now, some of the advantages of microprocessor include that it is low in cost, it has high speed, it is smaller in size, it consumes low power, it's versatile, reliable, portable, easy to implement, and easy to modify. Along with advantages, microprocessor has some disadvantages, which are its floating point operations are not supported, and sometimes microprocessor may get overheated. I hope this video helped you guys to understand the basics of 8086 microprocessor. So if you like this video, give it a thumbs up and subscribe to my channel. Thank you.